Hi guys. So today we're going to do a little bit of algebra review, and we're also going to expand on some things that you saw back in Algebra 1. So today is going to focus on factoring and solving quadratics. So the first thing we're going to look at is factoring, and as we talked about in class, this is very, very important for what we're going to do in this class second semester and also what you're going to do in your future math classes. So when we factor, it's kind of like we're reverse foiling. Okay, we're trying to figure out what factors will multiply to give us the binomial or trinomial that we have. So whenever it comes to factoring, your first step is to always take the GCF. All right, we always want to take the GCF. If there's not a GCF, we can move on from there. So if there's not a GCF and we have two terms, one of the things we look for is something called a difference of squares. So difference of squares is in the form of a squared minus b squared, where there's a minus sign in the middle and you know the square root of both terms. So something like example A is a difference of squares. The square root of 49x squared is 7x. The square root of 64 is 8. So that factors into 7x minus 8 and 7x plus 8. All right, then we'll go ahead and look at B. And again, with B, our first step is to take the GCF. It's hard right now to see that this is a difference of squares. But if I take that GCF out, then I'm able to factor. Because now I do know the square root of 25x squared and of 16y squared. So that would give me 5x minus 4y and 5x plus 4y. And that 2 that we factored as a GCF, we just keep on the outside. All right, then we move on to C. Again, this is still a difference of squares because I still know the square root of x to the fourth. That would be x squared. Square root of 16 is 4. So 1 is plus and 1 is minus. And then from here, the reason it's important to be really quick to recognize difference of squares is just because they come up so often. So x squared minus 4 is going to factor into x plus 2, x minus 2. And now this is factored completely. All right, D is another example of a difference of squares. Even though it looks different, the square root of c plus d squared is just c plus d. And we know the square root of 81 is 9, so we know the square root of both terms. There's a minus in the middle, so this factors into c plus d plus 9 and c plus d minus 9. So all of those are examples of difference of squares. All right, so the next ones we're going to look at, some of these have two terms, some of them have more. But again, our first step when it comes to factoring is always to take our GCF. And when we say GCF, we mean of the numbers and also of the variables. So if you look at E, both 10 and 25 are divisible by 5. If you look at your variables, x to the fourth and x to the seventh, the greatest common factor that could come out is x to the fourth. If 5x to the fourth is divided out of 10x to the fourth, I'd be left with 2. If it's divided out of 25x to the seventh, I'd be left with 5x cubed. All right, if we look at F, all three terms there are divisible by 3. So 3 comes out, and I'm left with this trinomial. From there, we would see, hey, does that trinomial actually factor? So I would look to see what multiplies to negative 10 and adds to negative 2. In this case, there isn't anything, so that is not going to factor any farther. And then G, even though it looks intimidating, G is just a GCF question. Again, we look at what's the greatest common factor between 3, 9, and 12. So that's going to be 3. And then we're going to look at each variable. Well, a cubed, a to the fifth, and a to the seventh, the most that can come out is a cubed. Out of my b's, the most that can come out is b squared. And then out of my c's, the most that can come out is just c. So if that divided out, of the first term, both 3 and 3 would be 1, a cubed and a cubed would be 1. B to the seventh divided by b squared would be b to the fifth. C to the fifth divided by c would be c to the fourth. Remember, when you divide those exponents, you subtract what they are. So like if I have, for example, c to the fifth over c, that's c times c times c times c times c over c. So one of those cancels out and you're left with c to the fourth. That's why it works how it does. All right, then we go to the middle term. 9 divided by 3 would give us 3. Then I'd have a squared, b, c cubed. Then on the last term, I would have 4 as my coefficient. If I had a to the seventh and I took out a to the third, I'd have a to the fourth. and b squared and c are already divided out. All right, and then again on h, first step is GCF. All three terms have a 4. All three terms have an x. So that would leave me with x squared minus 4x plus 4. Then from there, I would look and see, does that trinomial factor? So what multiplies to 4 and adds to negative 4? And that would be 2. So x minus 2 and x minus 2. Another way I could write that, though, is x minus 2 squared. And that leads us into the next type of trinomial that can be a little bit easier to see. So I'm going to go back up on our notes. And if you notice where it talks about this perfect square trinomial. So the one we just did was in that form. It was x squared minus 4x plus 4. So a perfect square trinomial means you have three terms if you take the square root of the first term and the square root of the last term. If you multiply them together and multiply them by 2, if you get the middle number, then it's going to factor into that perfect square trinomial. So basically the same binomial that's just squared. And that's going to come up a lot when we do difference of squares next class. So let's go ahead and look at a couple more examples of this. All right, so I is a good example. So look at the square root of the first term, that's 3x. The square root of the last term, that's 2. Well, if I multiply those together and double them, I get the middle term. So this is going to factor into 3x minus 2 squared. The sign is going to be the same as that sign that's in front of the b value. All right, so now let's look at j. Again, square root of the first is 9x. Square root of the last is 2. If I multiply them together and double them, I would get that middle term. So this is a perfect square trinomial. So 9x minus 2 squared. All right, so now we're going to look at what happens when the a value is not 1 and it's not a perfect square trinomial. Now, there are a lot of different ways to learn factoring in these cases. If you have a method that you're using that works well for you consistently, continue to keep doing it. But if you're not quite sure how to do these, I'm going to show you guys what is most likely the method you saw in your Algebra 1 classes. So our first step is we multiply the first number and the last number. And we want to find two numbers that multiply to that value. We also want two numbers that are going to add to the middle number. Once I know what those numbers are, in this case that would be -6 and -4, I'm going to rewrite this problem. But I'm going to change the middle number into those two new numbers that I just came up with. So -10x has been replaced with -6x minus 4x. Then from here, I'm going to use a process called grouping. So I'm going to look at just the first two terms. Out of those first two terms, 3x is my GCF. If 3x gets divided out, I'm left with x minus 2. Then I look at the next two terms. Whatever sign is there, I'm going to keep. And then I take my GCF, which is 4. If I divide out that -4, I'm left with x minus 2. And it would be minus because if I went back and FOILed it, I need to get what's already there. So now if my parentheses match, which they do, that's your first factor. Everything that's not in the parentheses, well, a little too far there, everything that's not in the parentheses is your second factor. So my second factor would be 3x minus 4. All right, so that's just an extra example we did in class, but we'll just go ahead and do that one real quick. So we're looking for numbers that multiply to 18 and add to -11. So those would be -9 and -2. So I'm going to split up the middle into those two numbers. I'm going to do my grouping. So out of the first two terms, 3x comes out. Out of my next two terms, -2 comes out. My matching parentheses are my first factor, and the other one is my second factor. All right, so on these ones, very similar process, but what's going to look a little bit different here are the terms. We're still going to follow the same steps. We just need to keep our terms consistent throughout this process. So I'm still going to look for two numbers that multiply to 2 times negative 12 and add to negative 5. Well, those numbers are negative 8 and 3. So I'm going to rewrite the problem, and I'm going to keep the variables the same as they were. So since it was x to the 4th in the first one, it's still going to be x to the 4th. Since this was x squared, my new numbers will still be x squared, because I'm still rewriting the exact same problem. Then from this point, I'm going to look at my two terms here. 2x squared would come out. I'd be left with x squared minus 4. Then out of these two, 3 would come out. I'd be left with x squared minus 4. My parentheses match. Everything that's not in the parentheses is my other factor. All right, looking at m, again, same process. 6 times negative 15 would be a negative 90. The middle is 1. My two numbers that multiply to negative 90 and add to 1 would be 10 and negative 9. So I'm going to rewrite this problem, and I'm going to keep the variables the same. So even though it looks a little bit different than the questions we're used to factoring, the process hasn't changed. We're just keeping our variables consistent with what they originally were. So out of those two terms, 2x comes out. Out of the next two terms, keep the minus. My GCF would be 3y. That leaves me with 3x plus 5y. My matching parentheses are one factor. Everything that's not in the parentheses is my other factor. All right, so this one's a little bit different. This is kind of what we call factoring in disguise. This is actually a very easy to factor question. It's just written in a way that makes it hard to see. So what I'm going to do is I'm going to replace this x minus 2 with a different variable. I don't want to use x because x is already there, so I'm going to pick another variable. I'm just going to say u, because that's just a variable you'll see in the future. So I'm going to let u take the place of x minus 2. So that would make this u squared minus 3u minus 40. Well, now this is a really easy to factor question. A is 1, so I just need the numbers that multiply to negative 40 and add to negative 3, and those would be negative 8 and 5. And now I've factored that. The problem is that's not really the factored form of my original question, because my original question didn't have u. My original question had x minus 2. So I need to go back and replace that u with the original x minus 2. Then from there, I can simplify it if it simplifies. And in this case, it will, because x minus 2 minus 8 is just x minus 10, and x minus 2 plus 5 is just x plus 3. All right, so again, one more, very similar to the ones we've done. We're looking for numbers that multiply to 18. They add to negative 11. So those two numbers are going to be negative 9 and negative 2. Rewrite our problem. Keep our variables consistent. Out of the first two terms, 3xy would come out. Out of the next two terms, minus 2 would come out. So my factors would be xy minus 3 and 3xy minus 2. So one of the things that's really helpful about factoring is it makes for a really easy and quick way to be able to solve quadratics. Now the problem with solving by factoring is that it doesn't always work. It only works when you have zeros that are rational. And we'll get into some other methods for solving other quadratics later on in this unit. But factoring is really the fastest method for solving and really, really useful. This is going to keep coming back up, guys. I cannot stress that enough. Factoring is one of the most important skills that you need to get out of this class. Solving quadratics is important. This is a really easy way to do it. But again, factoring is so, so, so important, not just for solving, but for other purposes we're going to use throughout the year for simplifying. You're going to see it come back up in your other later classes. It's just, you guys got to be able to factor. It's so, so, so important. Hopefully I've stressed that enough. All right, so if we're going to solve by factoring, what's different now is we now have an equation, okay? It's actually equal to something. In order to solve by factoring, you have to set it equal to 0 first. Okay, the reason for that, if you just have some factors, let's say I have these factors equal to 2. Let's say I have x minus 3 equals 2 and x minus 5 equals 2. Let's just say I take that factor and I try and solve it, and I say that, okay, well, x equals 5. The reason this doesn't work, if I take 5 and I plug it back in, yeah, I get that this factor is 2. The problem is when I plug 5 in over here, I get some other number. I get 0. 2 times 0 does not give me 2. All right? The reason we want to set it equal to 0 is because then it doesn't matter what the other factor is, because anything times 0 is 0. So now if let's say I solve this, x minus 2 equals 0, I get x equals 2. 2 minus 2 is 0. 2 minus 5 is something else, but that's okay because 0 times negative 3 is still 0. So it doesn't change that overall answer. Okay, so first step here is always set it equal to 0. All right, now this one right here, guys, this is one of the easiest questions to solve by factoring, and it is one of the most missed because you guys just don't see. Take the GCF, okay? So your GCF here is 4x. If that 4x comes out, you have two factors. One of those factors is 4x. The other factor is x minus 5. So to get your answers, set each factor equal to 0. So I get that x equals 0 and x equals 5. All right, let's go to the next one. Again, start by setting it equal to 0. This is a perfect square trinomial. If you don't recognize it, what multiplies to 9 and adds to 6? It's 3 and 3. So in this case, you only have one factor. So your only answer is x equals negative 3. All right, going on to the next one. Again, start by setting it. You have to set it equal to 0 first. All right, so here we're looking for what multiplies to 72 and adds to a negative 17. That's going to be a negative 9 and a negative 8. I'm going to split my middle into those two terms. And then I'm going to use my grouping. So I'll take out 3x, take out 4. So I get 3x minus 4 and 2x minus 3. So now to solve by factoring, take each of those factors, set it equal to 0. So 3x minus 4 equals 0. I get x equals 4/3. 2x minus 3 equals 0. I get x equals 3/2. All right, and this last one, this is another one that's kind of frequently missed because you guys will look at this and you'll say, hey, look, I can divide both sides by x. And I get 7x equals 10. So x equals 10/7. Okay, don't do that. The problem is you can't divide by x. If you divide by x, you're losing part of your solution. Okay, so while one of those answers is an answer, you also are losing part of your answer. So set this equal to 0, then factor out your GCF. In this case, my GCF is x. So now, yes, I do get 7x minus 10 equals 0. So x equals 10/7. That is one of my answers. But what I'm losing is this one right here. And another answer here is that x equals 0. So just be careful to make sure that you get all of your solutions. All right, so that is it for today with factoring. Again, guys, I cannot stress this enough. Factoring is really, really, really important. It's going to come back multiple times this year, and it's going to come back all the time in your future math classes. And it's going to be one of those things your teachers just need you to know how to do. So factor, factor, factor. Get the practice in.